The next example is involving trigonometric function. I is e to the x sine x dx. The integral of e to the x sine x dx. Here, this is not like the t square or something that I can reduce its power, because when I integrate e to the x, it gives me itself. When I differentiate, it gives me itself. So here, instead of aiming at reducing the power here, I will aim at the repetition of the sine function. Remember that the derivative of the sine is cosine. The derivative of the cosine is negative sine. So the sine comes back again and we can combine it. Or if you take the integral of the sine, it gives me negative cosine, and the integral of the negative cosine is sine. So again, the sine comes back. We are going to benefit from that. For this purpose, I will use this as u and this as dv. And let u equals e to the x. Therefore, du is e to the x dx. And dv is sine x dx. Integrate this, it gives me v equals negative cosine x. Put this back in the rule. Just to remind you, the rule is the integral of u dv equals uv minus the integral v du. Just sometimes if you don't recall it, write it down in each example you do so you remember it. Okay, so this is I now. U times v, it is negative e to the x cosine x, and then minus the integral v is negative cosine x, and then du is e to the x dx. This can be cleaned up as negative e to the x cosine x plus e to the x cosine x dx integral. Notice that this is exactly like the original integral. Meanwhile, the cosine is replacing the sine. So here, I'm going to take this and call it integral number 2 and put it back here as number 2 and work on it again. So the integral e to the x cosine x dx. If I take now e to the x as u, cosine x dx as dv, then I will say here let u equal e to the x, dv is, no, du is e to the x dx, and therefore dv is cosine x dx, and if I integrate the cosine, it gives me sine x. Now put this back in the integral. This is the rule, u dv equals uv minus v du. So number 2, the integral number 2 is uv e to the x sine x minus the integral v du sine x e to the x dx. Now this can be compared to the original integral e to the x. Let's look at this. It is e to the x sine x dx. So this integral is reproduced here, and I can say that this is actually the integral number 1. If this is the integral number 1 now, I can take this, put it back in 2, and find the following. Integral number 1 here is then negative e to the x cosine x plus integral number 2 is this, which is e to the x sine x minus 1. You see? This is produced from the first integration by parts process. This is produced from the second integration by parts process. When you add them or combine them, you get this one from the upper step, this one from the second step, and I have this integral that was a result of the second process of integration by parts. This is I put it here as I. Now look at this. This is I, and there is a negative sign. What if I take this to the other side? So I will have 2i equals negative e to the x cosine x plus e to the x sine x. And if I want I by itself, I just take 1/2 times negative e to the x cosine x plus e to the x sine x, and once I'm done, I will add c. This can further be simplified by taking e to the x as a common factor, and this becomes 1/2 e to the x times negative cosine x plus sine x plus c. Done.